Once you're done with checking any missing data and creating any necessary new variables, the next step is to generate descriptive statistics for all variables you use in your analysis. Descriptive statistics are really important as they would allow you to understand the basis of your variables. For example, if you want to understand the relationship between students' engagement and GPA, we first have to know where your sample is in terms of the engagement and GPA. Without understanding what the general trends are or how dispersed students are on these dimensions, the statistical information about the relationship between the two do not make much sense. Like, let's say the relationship was really high. But what does that mean when both engagement and GPA were high, or both were low, or maybe one was high but one was low? So we have to really know where the bases are by looking at the descriptive statistics before we even calculate further analysis. Furthermore, for some of you whose research questions are just to capture the trends in variables, the descriptive statistics will be only what you need to conduct. So it is also important for you to understand how to do those analysis. To calculate descriptive statistics, you have to understand the nature of the variable. So in particular, you have to determine if the variable is a continuous variable or a categorical variable. This is really critical because depending on how you determine the type of the variable, you will pick the statistics for descriptive statistics. And if you make different decision or wrong decision about the type of the variable, then your statistics that are analyzed will be wrong, which will then result in inappropriate conclusions. So what are continuous variables and categorical variables? If a variable can take on any value between its minimum value and its maximum value, it is called a continuous variable. Can you give me an example? Examples for continuous variables might include one's age that can range from 0 to whatever number it is, right? So it can be 1, it can be 2, it can be 4, it can be 6, 10, 65. GPA might be another example depending on how it's measured. So if we allow the data to have any numbers ranging from 0 to 4.0, maybe someone's GPA can be 1.1, 1.3, 2.5, or 4.0. On the other hand, categorical variables are ones that have 2 or more categories, but there's no intrinsic ordering to the categories. So gender can be a good example of a categorical variable. Depending on researcher, one might classify gender into 3 to include male, female, and other. Or one might decide to have more detailed categories. Furthermore, the values assigned to each category is arbitrary. For example, I might assign 1 to male, 2 to female, and 3 to other. Or I can assign 3 to male, 2 to other, and 1 to female. The numbers don't mean anything here, meaning that, like, but number 3 doesn't mean that it's bigger or better than 2 or 1. It's just arbitrary number that's given to each category, so we can use it in statistical analysis. Now, what if I ask students to report GPA but with limited options? For example, if I had students to report GPA as, is your GPA below 3.0 or 3.1 or higher? So it's only 2 options, right? Or if I give them some categories, like, oh, is your GPA fall into 0 to 1.5, 1.6 to 3, 3.1 to 4. These are 3 categories to measure GPA. So it's going to be a categorical variable rather than a continuous variable. How about variables on a Likert scale? For example, the academic engagement variable in this data, which is A11 through 7, they are measured on a 4-point scale, right? Where the smallest number represents the lowest level of engagement, and then the highest number is to capture the highest level of engagement. So the variable represents level, and it feels like it will be a, yes, continuous variable. However, the options don't allow one to have values of, for example, 2.5 or 3.5 between the numbers given to the different levels. So it might not be a continuous variable, but yes, a categorical variable. In fact, in a rigorous statistical sense, it is considered not really appropriate to treat these variables as a continuous variable. However, in our class, we will just treat them as a continuous variable. So whenever you see any of the Likert scale that measures level of something, we will consider it as a continuous variable. So how do we get descriptive statistics for a continuous variable? We have to measure something called measures of central tendency and measures of dispersion. So first, we have to pay attention central tendency, which means among the values for the continuous variable, what is the most representative value that we observe in our data. So the most used statistics for this purpose is mode, median, and mean. Okay, so these numbers will show what is the most, if we have to pick one most representative number to reflect the data, what would that number be? That's the information that we can get from mode, median, and average or mean. On the other hand, measures of dispersion shows us how dispersed the data points are from the representative number in our data. So minimum and maximum, range, quartile, variance, and standard deviations would help us understand this aspect of the variables. If you're not really familiar with those concepts, please go back to the HED 573 quant analysis lecture video and readings and review the concepts. Let's take an example using some of the academic engagement variables. Again, in this class, we will treat them, the Likert scale variables or, variables that capture levels as continuous variables. So how do we calculate descriptive statistics for the variable A15 and A16? So they are one, the level of students' engagement in terms of exploring topics on their own, even though it was not required for a class, and how often students accepted mistakes as part of their learning processes. So, and the values that are used for these variables are 1, not at all, 0, not at all, 1 occasionally, 2 frequently, and 3 very frequently. So let's go back to the data. So remember, for any continuous variable, we have to get the measures of central tendency and measures of dispersion. So we will try to, do these calculations using the formula that are provided, using the functions that are provided in here. So again, we will create new spreadsheets to show or contain different information. So for descriptive statistics, we use this new spreadsheet. So first, we can calculate measures of central tendency, maybe using average and median, as well as standard deviation. Because, in this case, it might not be really meaningful to look at minimum and maximum and also range because, the options are limited to be 0 to 3. So we already might have a good guess what minimum and maximum numbers will be for these dimensions. So again, we are interested in knowing these statistics, descriptive statistics for the variable A15 and A16. So to get the average, it's really simple. Again, we start the function with equal to sign and simply state average. And we have to tell Excel where the address of our observations for that particular variable. So in this case, we know that we have the variable A1 bar 5 in spreadsheet number 1 and column E. So we have to reflect that. So average, the address is sheet number 1, and it's contained in E2 to E38, parenthesis, and enter. So it shows us that the average level of students engaging with, exploring topic on their own was 1.885. Let's look at median. So again, same thing, we just call out median and tell Excel where the address is. So the data is contained in E2 to E38. And that gave us median to be 2. Let's repeat the same thing for variable A16, which was not accepting mistakes as part of learning processes. So that would be again equal to average, and the data must be contained in sheet 1, F2 to F38. So that's the average level of engagement for accepting mistakes as part of learning. And we will trying to get the median number for this particular variable. So again, we give the address here, sheet number 1, F2 to F38. Which also allows us to get the median number. And finally, we have to get one of the observation for measures of dispersion. So in our case, we'll use standard deviation. So again, we can get it. There are two ways. One thing that we have to cover is there are two ways to get standard deviation. So if your data is capturing sample of your population, we have to use standard deviation S. Whereas if your data contains your population, like everyone in your population, then we will use standard deviation P. So that's the only distinction that we will make for statistical adjustment, between sample and population. So again, we will do STDEV, and Excel will give you automatically the option. So we select sample and just simply tell Excel where the variable is. So we will repeat again that the variable is contained in E2 to E38. So this is the standard deviation for A15, and we will repeat the same thing. So standard deviation sample, and again, the data is in sheet number 1, F2 to F38. So once we get these numbers, are we done? No, of course not. We have to make sense out of this data. So how can we explain what's observed between the two dimensions of academic engagement? So for example, these two numbers, if we compare two dimensions of engagement, students tend to, if we think about how to interpret these results, we can first report the average for each of the variables. So we can say on average, remember that 2 was frequently and 3 is very frequently for these measures. So we can say that on average, most of the students were reporting that they somewhat frequently explore their topics on their own, even though it was not really required for the class. And this one also, suggests similar results. The average level of engagement was 2.2, which suggests that students were quite frequently accepting mistakes as part of their learning processes. And again, the median suggests that most of the students in the middle were choosing the option frequently as their engagement behavior. So that also suggests similar results with the average. Also, what these suggest now, standard deviation, is how dispersed students are from these average. So if we just compare the two options, they are somewhat close to 1, but they're smaller than 1. So maybe we can say that students' responses were not really dispersed from the average. So you can simply report that standard deviation for variable A15 was 0.37, 0.93. Which suggests that students are not really dispersed from the average. And same thing, for A16 variable, the standard deviation was only 0.76 if we round it, which is suggesting that students were not really dispersed from the average, which was suggesting that students are frequently engaging in this particular behavior. Also, standard deviation might be useful when you are comparing two variables. So in this case, even though this one suggested that both were suggesting that students are not very far from their average, at least there was more dispersion among students in terms of how students are exploring topics on their own compared to how students are accepting mistakes as part of their learning processes. So really think that these measure, standard deviation, explains how far students are spreaded from the average. And average is more of the number that represents where the most of the students are. So now, what if we want to create descriptive statistics for a categorical variable? So for categorical variable, the descriptive statistics we have to report is frequency. So frequency is basically counting how many observations we have for particular response within a categorical variable. We can see the example in a minute. So to get the frequency for a categorical variable, we will use something called pivot table in Excel. So pivot table is really useful tool in Excel for not only creating frequency, but also for other analysis that we will see later. One can use pivot table to subtotal or aggregate one or multiple variables, creating calculations and formulas by categories and subcategories that are represented as row and column in the table. So the name pivot table is coming from the fact that we can transform the row and column by rotating them around and view and summarize the information in many different ways. So we can make the table to focus on the information that we think is more important or interesting. So let's look at the example to better understand what this is. So let's say we want to generate descriptive statistics for one of the categorical variable in our data, which is age 12. So let's look at age 12 and really see why that's a categorical variable. So age 12 in this data shows employment status, and that is captured as 1 unemployed, 2 part-time, 3 full-time. So obviously this is categorical variable because the categories are again up to the researcher. Like someone can ask it as more employed, not employed, but this researcher decide to ask someone to indicate the employment status based on 3 categories, and decide to assign these numbers to these categories. But again, you know, in this sense, part-time doesn't mean that it's higher level than unemployed. And you know, like again, like number 3 full-time doesn't mean that it's better than part-time. It's just arbitrary number selected by the researcher, which then assigned to each category. So let's analyze this variable, you know, in terms of frequency. So now let's go to Excel and look at how we can actually create pivot table for this particular categorical variable. So in Excel, we will go to Insert, and you will see, you know, the first option called pivot table. So let's select this one. And it'll ask us to select the range, you know, where our data is contained. So let's make sure that, you know, every variable in our data and observations are contained, which is correct here. And we want to, again, create any statistical results in new spreadsheet. So we will select new worksheet as the option where the pivot table will be placed. So if we select, you know, OK, then now we have these pivot table fields and, you know, the area where we start building a report. So basically what we have to do is using these pivot table fields as a way to generate the pivot table. So remember, in our case, what we want to know is variable, you know, age 12, which was, you know, the variable that indicates, you know, one's unemployment or employment status. So basically, we have to put this variable in different locations to make sure that its information, which is frequency that we are trying to generate, is showing on this spreadsheet area. So what we have to do is put this variable to column or rows, and you will see that, you know, where the information is shown are changing. So in terms of generating frequency table, I would recommend you to put the variable to rows first, which will generate, you know, the categories that are included in this variable. And same thing, again, move the variable to values. So once the, you know, once it's there, you know, automatically Excel might put some of that variable reported to be here. But remember, what we want is not sum, but we want to make sure to report frequency of this variable for each of the categories. So basically, we want to see how many people responded as 1, which is unemployed, and how many people responded to be part-time employed and full-time employed. So the way we do that is, do you see this, you know, eye with the circle? So just click that, and it'll generate a pop-up which shows summarized by. Here we want to change it to count instead of sum. Say OK. And now, you know, each column and well, the combination of column and row shows the information that we wanted to know, which is the frequency. So how do we interpret these results? So there were 26 people's response that were valid. So the remaining were empty, which is missing data. So out of 26 people, there were 12 students who said they were unemployed. 9 students were working part-time, and 5 students were working full-time. And it is also possible to generate, you know, percentage for this frequency. So again, we can do, you know, calculation using, you know, formula. So saying equal to this number divided by the total number 26, and you know, we want to make sure to multiply it by 100, which will give us the percentage point for you know, how many students are not working. So same thing again, we can do put the parentheses first. So this number, 9 students out of 26 students, how many of them that is in terms of percentage points. So that means 34 points, 34% of the students in this sample are working part-time. And finally, we can do that, for students who are working. So, simply put, we can do about 5 out of 26 students, which becomes 19%, are, working full-time, right? So that kind of shows us the breakdown for the students in our sample among the valid, responses. So that's how we will generate frequency table, and sort of how to, that also was how to report the outcomes coming from the frequency analysis. So we will repeat the process for every single variable that we are going to use for our statistical analysis.